No rush, but that got started. You guys can get ready when you're,
Yeah.
you guys can start when you're ready.
We're ready. Welcome, everybody, to OWASP Nashville. First and foremost, I'm Eric Middleton with Endor Labs. This is Jamie Scott. Jamie will present here in just a minute, but first want to just thank Asurion and especially Jeremy for being so easy to work with. This was literally a breeze. I've done 3 or 4 of these in the Southeast in the last 6 months. This was by far the easiest and smoothest. So thanks again for hosting us. We'll do it again anytime. So appreciate it, Jeremy. We're Endor Labs. We're just a startup out of Palo Alto, California, focused on what's called supply chain security. And that encompasses a lot of stuff. But if you want to talk about what Endor's up to later, feel free to grab me afterwards. But today's talk is really around just kind of some open source things to think about. There's a lot of topics that are going on. There's a lot of AI possibilities that relate to open source that are stemming from what we're seeing from kind of the traditional open source code and repos. But I'll let Jamie get started. Just wanted to say hello and thanks again. Good to be in Nashville.
Cool. And while I'm getting set up, just by a quick show of hands, how many of you guys are developers in the room today? It's 1, 2, 3, 4. Okay, perfect. Are the rest of you students, security engineers? I know you're a DBA. Who here leads the security team?
No.
No?
Former code monkey.
Former code monkey. Ooh. Did you graduate or?
We have a decent presence online this time, and we didn't before, so we might have some code monkeys online.
Quick online poll. How many of you guys are code monkeys? I don't know if you can raise your hand, but online, you want to introduce yourself really quick? Linda, you want to kick us off?
Sure. I'm Linda. I, at Asurion, am the Director of Product Security Engineering. I am also the co-lead with Jeremy for the OWASP Nashville chapter.
Awesome.
Yeah. So, Chase.
Hi, I'm Chase Wilson. I'm a student currently at North Carolina A&T State University, and I was sent this presentation by one of my professors. So yeah, I'm just interested to see what you guys have to talk about.
Well, we're glad you're here. I think I'm probably how that happened, but we're glad you're here and hope you come back and have a good time. Jesse Ford.
Hey, sorry, was chasing the mute. I actually work for Asurion. I'm one of the network automation architects here. So I work closely with Linda and the security folks to automate infrastructure.
The code monkeys even work on the infrastructure side.
There's code monkeys everywhere.
Yeah. So Jevin and Marcel and Sheldon.
I guess I can go next, Marcel. I previously worked with Linda and Jesse and even Jeremy, who I've learned a lot from over the years. So I'm not a code monkey, but I did work in security architecture there at Asurion. So I'm familiar with those 3 on the call at least.
Glad you're here, Marcel. Thank you, sir. Used to know Jevin too from a former life.
I can go next. My name is Jevin Evans. I used to be on Asurion's vulnerability management team and the product development team. Now I'm in California as a federal contractor, doing information security insurance and different coding stuff in the cloud. So, yeah.
He said, you know what? Asurion makes it too hard. I'm going to go to the government and get an easier life. Said nobody.
Sure, that's what they say.
Sheldon, if you want to come off mute and introduce yourself, we're glad you're here. If not, it's okay.
Everyone has a shy guy in the midst. So,
All right.
I guess I want to just kick us off. My name is Jamie Scott. I'm a founding product manager at Endor Labs. All that really means is that I was super early enough in order to have the privilege of going through the cycle of getting new customers, building a product, and then managing the post-sales team, and then seeing how a company can be built from the ground up. So To me, that was the privilege and opportunity I had at Endor Labs. I've been there about 2.5 to going on 3 years, somewhere in between, I don't actually know anymore. But the reason why I want to talk to you guys today is to really define to you what supply chain security is and some of the pain points that exist in the market today. And what I want you to take away today is a taxonomy of known attack vectors in the market or a taxonomy of supply chain attacks. So what is open source security and open source for those of you who don't know? There's 3.3 million open source projects that's growing at about a 33% year-over-year rate. Harvard came out and said that open source is a $7 trillion asset. Nowadays, most people reuse more code than they write because it's easy. I mean, at the end of the day, what are you gonna do? Are you gonna write a PhD PDF downloading script or library, or are you just gonna take one from open source because there's 800 of them that have already been done? So at the end of the day, to me, open source is about software reuse. It's about acceleration of innovation. And because at the end of the day, in today's competitive markets, if you are not first to market or quick to market, you're gonna fall behind. And open source is how you can establish yourself as quicker to market. Now, I just gave you a lot of marketing bullshit, but at the end of the day, what is the result of this? Because that value proposition is true. And what developers imagine that they got is Disneyland. If I can reuse software to deliver my feature fast, I don't have to think twice as hard. You work smarter, not harder. So they were in this magical realm where they thought software reuse was going to accelerate innovation. And it did. But they also got dependency hell. Who here is familiar with what dependency hell is? Do you mind giving me a short definition for you? What's your experience?
You can't upgrade your database. We're 4 versions behind on this and that and the other, and we can't change this one because our biggest customer depends on that one and they won't upgrade their software.
Anyone else have a definition for me? There's a couple developers in the room. No. Oh, man. I'll give you a funny example. I was looking at some of the breaking changes in the Java Elastic client and found that there were approximately 4,000 that were preventing a vulnerability update at one point in time. There's someone joining. And the reality is that when you manage software, we have also got complexity associated with innovation. No one has a dependency removal engineer. Everyone is scared to take away code because you never know when you're gonna fuck shit up. And at the end of the day, you see that a real place that we live in is the uncertainty of if my software will continue to build, if my software will continue to function, if we update or modify a version. This has created a fear in the market because at the end of the day, people just want to get on with their days. No one likes getting called at a Friday afternoon at 3 p.m. and being told, hey, you can't go out to party. Go ahead.
It's hell when you have people like me in security say, you have to upgrade because you have all these vulnerabilities, like patch your stuff. But when you do, you introduce breaking changes that may or may not even be in your control.
So today, I not only want to define to you what is a taxonomy of supply chain risk, but talk to you about some of the pain points with breaking changes along the way. So that's the purpose of this talk. Before I even do that though, how many of you actually understand what dependency management is in any material depth? And I'm going to explain it anyway because there's a handful of students in the crowd. But who here manages software updates regularly? You are a very lucky audience, let me tell you. So what is dependency management 101? At the end of the day, what happens? When you choose to reuse software, depend on software, you are making a trust choice. You say, I trust Lodash, or I trust or the request library in Python. But when you implicitly make that trust decision to reuse software because it's going to help you develop something faster, you also establish a chain of trust with not only the software that you trust, but the software that they trust and the developers associated with each. Now, I think the reality is that if you look at Jackson Databind, which is one of the most popular libraries within the Java ecosystem, you'll also find that it's also the #1 cause of known vulnerabilities by statistical measurements, that there's really only 2 people who are managing this software. You've got one guy who has done it effectively his entire career since inception, and someone who just started like last year. And you are choosing to establish a trust relationship with not only your application trusts what is called the direct dependencies. These are the things you choose to use in your code. And transitive dependencies are things that your direct dependencies choose to use in their code. And the reality is that how much would you say the vulnerabilities or potential security risk exist within your direct dependencies overall? If anyone wants to take a wild guess, I'll pass out fun churros. Give me a number between
Repeat the question.
what percentage of known vulnerabilities do you think exist within your direct versus your transitive dependencies?
95.
You've seen this, haven't
I haven't.
you? He is exactly right.
Where's my churro?
Yeah.
I got it.
Please, actually.
Promise I'm not a plant.
I swear. All right, did
That's
you do this?
crazy.
So 95% of all known vulnerabilities exist within transitive dependencies. And the reality is that this is much like a party. When you create an application or when you start a party, you invite your friends. And your friends invite their friends, and it's not your friends who destroy your house. It's their friends. And hey, I did a lot of parties in college. This was exactly what happened. I didn't know the people who wrecked my house. But this is the difficulty in that you choose to make a conscious choice on who to bring into your app. And the issues that exist that we ask our developers to manage generally aren't a conscious choice of theirs. So how do you start to manage this effectively? And how do you understand the risk associated with each one of your friends' friends who came to the party? So I want to give you an example of what we would call potential supply chain risk. Gorilla Toolkit is one of the most popular web frameworks in the Go library. And the reality is that this is a library that has 100,000 weekly clones. If you're not familiar, that's just downloads on GitHub. It's used in over 90,000 other repositories. So a lot of other people in the open source ecosystem depend on it. It's got 18K stars, that's a vanity metric. And it's the most popular HTTP service for Go. The reality is though, that the developers of this in December 2022 literally just stopped maintaining it. So new vulnerabilities come out, what happens? They ultimately said, I don't have the time to do this. And the important thing to remember is that we have a $7 trillion asset that the entire economy depends on. That's maintained by a bunch of volunteers. This is just the truth. And the question from your perspective is, there's no shared responsibility model with open source. It's not like AWS where AWS owns this part, you own this part. You own everything. When you trust software, you own it. You can't go to an open source maintainer and be like, when are you going to fix my vulnerability? Here's a questionnaire, which for what it's worth actually happens on the regular. You make a conscious choice to trust these things. So you have to be asking yourself the question, where am I using this software? What do I replace it with if I need to replace it? Which of my applications actually use it? And am I exposed to any material security risk? PyTorch is another example. How many of you are familiar with the concept of dependency confusion? And this is about to get 201 level, so I'm sorry in advance for those who become a bit less technical. But familiar? Okay. So what happened here? PyTorch is a software library that is kept outside of PyPy, which is the package repository for Python, and generally the default of package managers like pip. So if you're a Python developer, how do you install software? You do a pip install requests, pip install some library name. And if you had to install PyTorch, you had to first connect to a different repository because it is not available in PyPy, and then you could download it. And what dependency confusion is it's tricking the package manager into downloading a package from one location instead of another. So what happens in pip? Pip first looks and says, I'm going to look at the PyPy registry, which is where most open source software is kept in the Python ecosystem. And then you start to define what priority order afterwards you want to pull down dependencies from. And this is a process called dependency resolution. Now, what happened in the case of PyTorch? Well, because PyTorch was commonly in a Facebook hosted and owned repository, someone just published it to PyPy with the exact same name. And they modified the code to make it malicious. Now, luckily, this was a researcher or a joke, but it emphasizes the point where all you had to do is take software that was commonly used, change the code a little, and just publish it. And now you have thousands of people around the world consuming your code and trusting you. And this is as simple as tricking a package manager. This isn't something complex. It's a download code and publish it another place with slight modifications. This is the reality of supply chain attacks and why AppSec starts to scare me. And I say that because of the audience here, how many of you are keeping an inventory of where your software comes from?
I think every place I worked always had an independent, their own repository for that kind of thing, version control too, yeah, that's the way to help prevent it, right?
That is the way to help prevent it, but the question is, are you always connecting to your Artifactory? Do you block external artifact repositories? Or do you assume that people are always connecting through Artifactory, Nexus, insert random artifact repository that isn't those two in the 5% of things that are actually used afterwards? Beyond that.
Yeah, that's it. About the protocol in the company, right? It's a good point.
And do your CI tools that do your automated builds use the same internal artifact repository? Maybe, maybe not.
What I've found is a lot of people think that they're going through Artifactory, and that's true. A lot of people don't necessarily know that. And the problem then becomes, what is dependency confusion? You assume you're going to Artifactory and you're not set up to do that. And you're not blocking external repositories. Dependency confusion can simply be, I've discovered the name of a private internal package that you use in your environment. Oh, you can download it from PyPy now. I published something with the exact same name. And this is what dependency confusion is overall. So do you track that? Do you block it? Or do you assume that your developers are going to know? Are you constantly publishing the same name in the PyPy repository to protect yourself? Some people do preventative squatting. But these are the things that most organizations I know never think about. Most people are stuck in the land of vulnerability management and license compliance. And honestly, most people are in the land of vulnerability management and forget about license compliance. But people do that.
Yeah, for the college students in the room, does that make sense? Like how this could become a problem where internal name that you think comes from the private internal repository is actually out on the public internet and you by default go to the public internet? You get the poison package that has some malicious code.
And I can draw this on the whiteboard if it doesn't make sense. I'm happy to.
Following.
You want me to?
No, I mean, I'm following.
Okay. So, I mean, the question still becomes, hey, what version are you updating to? Are you pulling it from the right location? Where am I using this? What applications are affected? I think the reality is that open source is more complex than most of us think. And this becomes a question of where are we wasting engineering cycles? A lot of teams in the proxy that we use primarily for vulnerability management or security risk is what's called a CVSS score. CVSS score is a standard developed by an organization called FIRST that measures the severity of a vulnerability. So when someone says this is a critical vulnerability, they're saying this has a CVSS score of 10. The reality is that we use that score affecting a specific version of a software component as our proxy for risk. Doesn't necessarily mean you even use the vulnerable functionality. And the question becomes, how do we more effectively manage our engineering time? Because we don't necessarily know and we don't want to waste our engineering cycles. We're a business at the end of the day. If we spend 50% of our time doing security updates, only 10 of which actually matter, well, we just lost 40% of our productivity that we could have used to compete. So we want to reduce engineering cycles, but we also want to manage significant operational risk. So we talked about dependency confusion. This is just one example, but we effectively sit in a world where much of software is unvalidated, much of it is unused, much of it is outdated. I actually regularly talk to people who are still on Java 6. And if you don't know what that means you're building Java software using a version that was end of life in 2011. So, gosh, I didn't even graduate high school then. So, at the end of the day, the question becomes, how do we start dealing with emerging attack vectors? Because the compliance obligations we face are vulnerability management and license compliance. Those are the things we have to do. But as security teams, how do you manage things like dependency confusion, understand where your software is out of date, and do that in an effective manner? And in order to support this, I want to present to you a taxonomy of open source supply chain attacks. So a lot of people say supply chain security, right? It's just a lot of marketing that becomes diluted over time. So I want to create for you, not marketing language, but a standard definition of what these attack vectors actually look like. So first, how do you conduct an open source supply chain attack? You can either develop and advertise a distinct malicious package from scratch, create something useful, and then mess with people. You can create name confusion with a legitimate package. So that's an example of dependency confusion happening with PyTorch. Or you can subvert a legitimate package. And what does subverting a legitimate package look like? Well, before I go into this, by a quick show of hands, how many of you which of these do you think is the most common open source supply chain attack that exists today? How many of you think creating and advertising a malicious package is common? By creating name confusion? And what about subverting a legitimate package?
That's more work.
So 63, okay. And I can't ask the audience online, sorry.
You can, we can, I mean, I don't have the whole
Yeah.
set up, but we can make him come off mute.
Questions? Yes.
So
One guy was saying he was voting free. That was what the free was.
Yeah,
perfect. So the correct answer is that 60% of all open source supply chain attacks actually come from attack vector 2. Hypo squatting is easy, guys. And I think you said that's hard. That's the net of it, is that this is advanced, cool, sexy. This is hard because you have to build something useful.
That's easy.
And this is just taking advantage of human nature. So what does this look like in practice? Developing and advertising a malicious package from scratch. At the end of the day, let's say you're a dev. You just need to get a job done. If someone tells you, I have just the thing, it's gonna be useful to you. Cool, just use it. How does a developer pick code? Well, you're gonna do it a few ways. This was on Stack Overflow, copy and paste. The ChatGPT told me to use it, copy and paste. I Googled it, copy and paste. The frequency of which people actually know the libraries that they're using is fairly low. I won't say that people don't think to, but that comes with time. The reality is that we make things easy. And you don't know if something is useful or something is harmful often. One of the funny ways that I like to look at this is people have developed popular Python packages that upload your AWS keys and environment variables. Now, you don't start by building something you start by building something useful. Then you update the version and wait for people as you introduce the malicious software. So
That was me saying, I'll, to the people online, I'll get their attention, your attention if they have questions.
perfect. So the reality is that creating something useful becomes a call option on attacking the world. We'll give you a quick example that should make you somewhat fearful. One of the most popular JavaScript clients used in the world is created by someone who is going through financial hardships. I want to say, oh gosh, this is going to bother me so much. I just blanked on his name. But this guy accidentally killed a drunk girl in Russia and was sued, very financially leaned into by the government. And he owns and is the primary maintainer for something embedded in Netflix, something embedded in Google. I mean, this is all over the place. Eric, can you look up this name? It's gonna bother me senselessly.
Axios developer?
Sorry?
What's the package? Is it Axios?
Sorry?
What's the package in the JavaScript community? Is it Axios?
No, it's not Axios. It's fuck me. Oh, well. So when we start and think about it, what would be the first thing you did if you had financial hardship and you had the maintainership of one of the most widely used JavaScript libraries in the world? JavaScript is run client side. I would start crypto mining everyone's computer. And this is just the reality of where we live today, especially because JavaScript, most people don't even look at things before they update them. It just happens automatically. By a quick show of hands, how, and actually, can I just ask for one guess? From two of you, I'm gonna pick two random people. But how many software components or dependencies do you think come in every time you import just one JavaScript package on average? You wanna take a guess for me?
50.
Close. Can you, Tiff?
I was gonna say hundreds, but 50 sounds better.
So on average in JavaScript, when you import a single software library, you are importing an additional 77. In Java, that number is 14. In Go, that number is like 3. Go is the best programming language. I didn't say it. So if I want to create a name confusion attack, this becomes,
Dennis Pushkarev,
what's the library name?
popular core JS library.
Core.js, thank you.
Core JS.
Core.js is that library's name, thank you.
Did he actually exploit it?
He has not exploited it. He appears to be trustworthy, we are monitoring. But I'm still saying he has more ethics than I would have, and I'm a cis. So creating name confusion becomes one of the most popular paths in order to exploit a supply chain. And what does this actually look like in practice? Well, I have good old URL lib 3.1.2.1.1 tar gz. I know that's exactly what I need. Here you go. Here's URL lib 1.2.1.1 tar gz. Now, not many people are going to notice the subtle difference, but one character up, you're missing the 3 in URL lib, is going to create something where you don't think you've made a mistake, but you've downloaded something completely different. And this is just exploiting human nature. Right now, I'm typo squatting like 10 of the most popular GitHub actions by basically forking them, modifying their code very marginally, and creating organizations on GitHub that are, I own AWS Actons instead of actions without the I. And it's pretty easy to fork some things and modify code and wait for people to make a copy paste error. This is the reality that we live in. And I'm not joking. You can look up, I am a teapot 418. That's my GitHub handle. I own that organization. So what does creating name confusion with legitimate packages mean? So to give you a quick example, everyone's heard of a typo squatting attack. This is the most common form of attack. We have full incident response teams looking at typo squats and buying subdomains. I'm sure Asurion has that team. We live in a world where trust is a commodity. Sentinel-1, for example. Someone created a Sentinel-1 SDK and published it. And people started to use it. Now, little did you know that those people were relying on the trust in Sentinel-1 as a huge security company. Sentinel-1 doesn't have a Python SDK. People were still downloading it and trusting it. So the reality that we live in is we have established trust in brands, in people, and in human nature. And we should not trust humans to not make accidents. There is a difference between malicious behavior and an accident. And I mean, everyone in security awareness has always said you can't patch stupid. You can't prevent typo squats from happening. Now, you can put detective controls in, but preventative controls tend to be a pain because of higher false positive rates. So how do you start to manage things like a developer misses a character unexpectedly? The last thing and type of attack is subverting legitimate packages. And I'll give you some fun examples because this is where the sexy side of supply chain attacks actually come in. So let's say I've been using this package for years. It's time to update. What do? Here's a regular update. Don't think about it too much. If a new version of a software library that you always use has come out, what are you gonna do? Are you gonna do a full source code audit? Nobody has time for that. The reality is that, in fairness, people in the safety industry do actually do that. Most people have no time for that. And most people are gonna say, thanks, I wasn't gonna check it anyway. Let's talk some examples. One of my favorite supply chain attacks is as simple as taking over a custom domain. If you have your own domain name instead of a classic Gmail account, and you publish to NPM that way, using that email address, and that domain expires, what do? If you want to take over a popular software package, you buy that domain, create the email, and voila, you now have the forgot your password through. And this is why you start seeing package managers or package repositories require two-factor authentication from large maintainers in industry. And this is really a change that has started to take place over the last year. And expired email domains can really just be a quick script for your targets. I mean, who doesn't have MX tools and a credit card? The reality of subverting a legitimate package, and I feel like this might be overkill, but who's heard of XZ tools? Or the XZ supply chain attack that was happening?
My job to handle that from here.
I think we got lucky as an industry. If that made its way into something that was more commonly used, we would have had a major incident. I think as an industry, what happened? Someone who is kind of believed to be in China but unconfirmed was able to become a maintainer of a very popular software package that's installed by default on most operating systems. And by becoming a maintainer, they maintained it for months. The one core developer of this tool called XZ began to trust them. They made them an admin. Over the course of months, they contributed real code that helped the community. And then one night they submitted a signed package with a backdoor in it in order to be used to backdoor SSH. The reality is that all you need is a little bit of trust, and you can exploit that trust. And we trust volunteers in the open source community because honestly, it would be difficult for our business not to. This is a risk that we have accepted as an industry very broadly. The question becomes, how do we manage this as an industry? So how do you start to actually manage and protect yourself? Now, I like to frame this in different levels of maturity. Most AppSec programs have probably heard of SCA, Application Security Testing, RASP. These are a software composition analysis tool that's going to link you to known databases of malicious activity to give you visibility after the fact. It is a detective control, it is not a preventative control. Things like RASP, things that prevent script execution, those can start to be a preventative control. But most of the industry, they're talking about basic patch management, SCA, SAST, DAST. This is the world we live in the first phase of maturity in AppSec programs. People will occasionally audit their open source code. The reality is that a lot of people do source code investigations, but they're not doing that for every version of something that they have trusted once. And let's be honest, most people don't actually have reproducible builds. They just upgrade by default. The other things that we can start to do that are more advanced, that candidly are not for the faint of heart, are things like code signing, building software from source, and starting to go down the path of reproducible builds. If you are a JavaScript developer and you do npm CI, you always download the same software. If you do npm install, you download different software every time. And if you say, are you using a lock file to a JavaScript developer? They'll be like, yes, I have your lock file right here. If you ask them if they're actually using it and how they build their software, you only actually use a lock file if you do npm CI when you build software. npm install, gonna create a new thing every damn time. So what does that mean? That means 77 times however many software packages you build. New ones get published into the open source ecosystem. Most of the time in JavaScript, you're just going to download the latest version each time you do npm install. This is by starting to have audit conversations and security conversations as simple as, are you using npm CI? Are you actually using the lock file, or how do we get toward reproducible builds? That's how you can start to meaningfully reduce supply chains attacks. That being said, this is not the maturity of most of the security industry today. We can do integrity checks on dependencies, which is also what npm CI would do when you download. But most people are still doing npm install in CI, unfortunately. And we learned the hard way that you're not checking the software that you trust. You can do things like code signing, typo detection, preventative squatting. If you, an example of preventative squatting would be, I take a namespace of my internal repository and publish that to an open source repository. So let's say internally in the artifact repository of Assyrian, I namespace everything with @Assyrian, and that's my standard practice. I'm also going to take @Assyrian in npm and make sure that no one else can publish under that namespace to preventatively squat myself. Now, who actually does this in this room, or who has seen this actually done in this room? I've seen Microsoft do it. Kudos to them. I'm not I don't even know how to Microsoft, but I've tried to take enough of their things where I respect that they have always defeated that. But these are the things that security engineers should focus their attention on. The reality is that we're focused on a huge list of requirements that don't necessarily impact security in a lot of cases. So what this has created is a sense of mistrust between development and security teams. And that's not because developers don't want to work with security. Generally, they always want to do the right thing. But they don't want to be in the way, and they want to show evidence of meaningful impact. As a security architecture team, I would focus on things like preventative squatting and building software from source. The reality is that most people live in a world where they're handing checklists to developers and saying go, and not helping. How do we start to meaningfully bridge this gap as an industry is one of the first problems that we should all be focusing on in order to advance the industry today. I want to pause there. I want to switch over to some breaking changes and what that means for the industry. But do you guys have any questions before I move on? On the phone?
Nothing online. Let's say come off mute.
Did I put you guys to sleep?
No, we're good. We're good.
I'm glad someone answered it. I was gonna cry inside. So, beyond a list of security requirements, what do we actually make developers deal with? Because a lot of us are focused on vulnerability management. And that's a good thing. We know that one, there's a compliance obligation to manage known vulnerabilities, but two, it's a low-hanging fruit for attackers. So how do you manage them effectively? Becomes the key question. And what are the frictions with managing them that create churn with the development team and security relationship? I think this is a common conversation that a lot of people in vulnerability management have. Hi, can you change this package? It has an issue. I tried to change it, but everything is broken now. Okay, our policy is a 7-day SLA. Let me know when it's done. I think SLAs or minimum risk acceptances are actually unrealistic in a lot of practice. Still good to put pressure on people to fix things. But one, you have to ask yourself, if it's going to be hard, is this important to spend my time on? And how do we not create compliance theater and actually focus on risk reduction? So I want a quick poll for you guys. There's two types of breaking changes. This is an example of an API incompatibility. or a syntactic change? Who here can tell me why the bottom is broken and the top works? I'll give you about 30 seconds. Oh, you told me you took Java, come on.
But the top one's looking for an integer, and the bottom one's, you're building the string and you're passing.
That's correct.
Depends on the language you're using. Some of them let it go, some of them won't.
So in the example of Java, this will create a compilation error because of this API incompatibility. So if something as simple as an integer changes to a string, and or a string is now expected, this is going to actually break the application. And the reality is that a lot of teams don't have visibility into when this happens, when we ask them for a software update. So this is an example of a behavioral change or a syntactic change. Someone else other than the first prize winner, last one, tell me what's broken in this one. This one is made a little bit more obvious because it's a bit harder.
It's only because I've broken my code all these ways, so.
Absolutely fair.
It's rounding it.
In what way?
This one is -2 and that one's -3, but that one also adds a 0.5 to it.
So if your client code expects 2 or -2, and you upgrade and you start getting -3, you've now broken the application because of unexpected behavior. This is often why developers fear making updates, because they don't understand, or it's really hard to test for something like this. And it's not hard to test, don't get me wrong. But test coverage is lacking across the industry.
Bingo. I was gonna ask that question, like, what's your perspective on how much a lack of test coverage is used as a reason why developers can't or shouldn't do their due diligence here and upgrade? Been plenty of conversations I know I've had with developers here who, because of their bad test coverage, if it exists at all, they actually can't upgrade because they don't know what's going to break. But have they written some test coverage to say, maybe if I take an integer when it should have been a string and I know it broke ahead of time, I can answer the question of will this dependency change actually impact me?
And I guess it depends on language and it depends on compiler. It depends on a lot of things. At the end of the day, that syntactic change I showed earlier, that's gonna throw a compilation error. If you update, you won't be able to build, you'll know immediately. The behavioral change, you'll sit there until something is messed up in a lot of cases. And yes, it depends on language. Some of them will throw build errors to make it obvious. A lot of the times that won't happen. So what does academia say? Because we've got a lot of students there, so we might as well put the PhDs up on the wall. So Joseph Hershiff, he is a PhD on our team developing static analysis. During one of his studies prior to joining Endor Labs, what he found is that test coverage in direct dependency calls is limited, with half of the projects in well-tested Java projects only covering 60% of direct dependency calls. For transitive dependency updates, this coverage drops dramatically to 21%. If you look at Google's best practices outside of these PhD studies, Google's quote unquote acceptable test coverage is 60%. Good is 70%. Best in class, 80%. We at Endor Labs break our builds if we do not have at least 70% test coverage. That's best in class for software industry. A lot of us live in the world where we've got 30 to 50% test coverage. And it's actually a good thing, believe it or not. Because if you sit there and test every scenario, I mean, when are you actually going to deliver business value? So there's always a trade-off. And yes, this does impact the security industry. But as a product manager, if my dev team was doing 100% test coverage on everything, I would be concerned. And as a security practitioner, I would love that. But I also know that they're gonna get 100% unit test coverage and still fail during integration testing. I want to show you a blog that is being written right now and hasn't been published, so sorry. And if I were to just zoom on this is our reality of test coverage today. Right? This isn't gonna fail until scale testing. A lot of product managers I know would be like, that's an MVP, guys. And I would.
MVP. Minimum viable product. Water goes down the drain, right?
Yeah, it works. It doesn't work if you turn it up all the way, but it works. Right, now, there's gonna be a segment of use, as a product manager, what do I see when I see this? Hey, there's a class of users where it's just gonna work, they'll wash their hands delicately. Some people are gonna turn it on all the way and then splash everywhere. I'm not gonna sell to them, I'll sell to the delicate darlings. Crap, I don't even know where my DARPA went. Well, that's not good. Oh, Nashville. So, when injecting simple faults into software, what this study found was that 40% of the time, the faults and direct dependencies were not detected. Or, sorry, only 47% of the time they were detected. And in transitive dependencies, that was detected 35% of the time. This is the world we live in. These are the well-tested benchmark, not the poorly tested benchmark. Breaking changes aren't sufficiently visible across the industry. A study by someone who I actually don't know, where I do know the rest of these authors, revealed that 21.9% of breaking changes in Maven Central are not documented. So you've got one end of the spectrum where there's full migration guides, read Spring. And you've got another end of the spectrum where breaking changes are put in and known, but not documented in any form of issue, any form of release tracker. So these things aren't visible to a lot of developers. And even if you ask them to update, if 21% of them aren't documented, they can't go look and be like, oh, this might mess with me. They're spraying and praying these updates. Now, automated updates can create concern, but they still help the industry. Breaking changes, 62% of developers list breaking changes as a top concern. And understand the implications of changing a migration effort becomes a burden for them. Developers generally feel overwhelmed by the frequency of updates when using automated update tools. And that creates notification fatigue. What did we do at Endor Labs? We turned on Dependabot for every update in existence. And we quickly turned it off because we got hundreds of pull requests. Then we updated that with reachability analysis to say which of these actually impact my application. And we found the 10 updates that we actually wanted to do. Now, how many of those broke? I can tell you I had to update one of them. It was my package. I was sad because I didn't know how to fix it and I had to ask our CTO and he did it. I think the reality that exists today is that developers recognize the tax of breaking changes loud and clear. There's a cost of a breaking change that can be devastating. And open source makes a trade-off. They need to break changes to innovate. Maybe they want to stay up to date. Maybe they don't want to keep supporting Java 6 and actually want to be on 21. Those are breaking changes. People hate migrating, but at the end of the day, there's a trade-off between major for innovation API refactoring and trivial, you're gonna hurt all of your clients refactoring. And the reality is that a lot of people do both. Now, if you look at semantic versioning, this is what we were promised as the path to managing things more effectively. If you have a major release that's gonna break stuff, minor release isn't gonna break anything, it's gonna add functionality. Patch release isn't gonna break anything, it's just gonna fix things. What actually happened? Well, major releases do generally break everything. On a study of 1,240 Java vulnerability updates. This is only to update from a vulnerable version to the latest non-vulnerable version. Guess how many minor releases had potentially breaking changes? Just throw out a number.
20,000.
Percentage, I mean.
30%.
What about you? You tend to be our magic number guessing.
75.
95.
I was gonna say that again, but I'm like, I can't stick twice.
It was actually 94. That's the exact number. And patch releases had 74% possible breaking changes. Now, to be clear, that doesn't mean that your app is screwed 95% of the time. A lot of those are unused functionality, things that people are refactoring away or deprecating. What actually matters from your perspective is if a breaking change that occurs. That shifts the number down. That being said, the fact remains that we cannot, as an industry, completely trust semantic versioning as a source of truth for updates. And this is what many package managers has built in as a promise. If you look at JavaScript, you just update automatically for minor versions. Unless you're pinning a version, which candidly JavaScript developers hate. So how do we prevent taxes on our teams? And how do we manage software reuse? I'd like to open it up for questions. I can tell stories all day, but I'd like to hear your stories because I've been talking far too much.
We were always, not my current job, but my past job, just very careful about what packages we use. Like, I was smiling when we were talking about semantic versioning, because semantic versioning doesn't do anything if the guy maintaining the package doesn't know what semantic versioning is, right? So we would try to do due diligence on who's maintaining these packages, what kind of change processes, what kind of testing coverage they had within their Git repos for that, how they were doing builds before we decide whether we were going to use something. And if something was particularly tricky or we had doubt, we would fork it, build it ourselves and send it to our tech and manage it that way to try to for this. But the problem we had, team I had was running a team of like 6-7 developers. And it was easy enough when you have 6-7 guys. But what do you do when you've got 1,000 developers, right? Learning different languages, different kind of things. That was kind of where the challenge was for us.
A lot of organizations speak standardization. And are you familiar with Bazel?
I'm sorry?
Are you familiar with the build system Bazel?
Sorry, one more time?
The build system Bazel?
No.
So Bazel is a common monorepo build system that was developed by Google for their internal use. And what it did was it established the pattern of your software dependencies used across the whole repo are always the same. You can't have a different version. If you update one version in your workspace, well, you have to update every version for every software package. And this at least established the fact that you had standardization on a common version. A lot of organizations do try to do standardization on a common version to prevent proliferation. That being said, the reality is that what you've described to me is more mature than even the people who have recently gotten funded.
It's really tricky with like Agile and moves to like microservices and stuff like that. We're trying to give teams independence it's hard to do that while maintaining visibility.
And that's, I think, there's two ways to manage that effectively, in my opinion. You have a team that is a strong platform team. You can't, there's always a trade-off between independence and centralization. A strong platform team who can develop enough standard patterns to start being reused across the organization has been the most effective way that I've seen that done. I work with a large technology company that is, sorry, I wouldn't call them large, but large enough to be publicly traded technology company that is much more advanced than I frequently see, where they have a platform team that develops libraries for common patterns like authentication and across different languages, and they give them to their development team. If you can make things easier, you can be more successful. That being said, like, I think this is like open source, this has to be an accepted risk to a degree, and we can only, don't let perfect get in the way of better, is the way I like to think of it. We need to encourage our teams to do the right thing. And the more we make it harder, the less likely that they're going to actually do it.
Yeah, like I always, not trying to dominate the conversation. but, like,
No, you're doing great.
I always felt like developers, people say developers don't care about security, and I don't think that's true.
No,
They just don't know how to do it. And they don't know how to do it, oftentimes they're not given the tools to do it in an easy way.
Well, I'll put it this way. I do think that developers care about security. Oh, I have gone, and during our early discovery at Endor Labs, what I did was I asked tons of developers, stack rank your priorities for me. Security at its highest was number 6. What does that mean from a security engineer's perspective? Well, if people are listing features, bugs, performance issues, tech debt, it's kind of their general top priorities. Well, that means that security is something they care about. They know it's important. But are you going to act on things that proactively that aren't in your top 3 priorities? And I think this is the reality that we live in. They do care. They're passively aware, but it's not something they're incentivized to do. And the economics of security are that how many people get bonuses for being more secure? I mean, Microsoft just did it, but like, Microsoft is also going through the pain of having its largest customer in the world, the US government, be like, you're not secure. So these are just the trade-offs that we live in when it comes to economics. They do care, but it's not something that is in their top 3 priorities. Disagree? I would love to.
Oh,
have
no,
some.
I don't just, I'm just shaking my head. There's too many stories. My impressions from within the warm womb of my DBA land, watching all the crazy developers around me, is standards and innovation are fundamentally conflicted. You can't have 6 of the brightest engineers on your version 1 startup product and come up with a standard across all of them, because this guy said, hey, I've done this before and I'm gonna do it with Postgres. And this guy says, oh, no, we're doing MySQL. Well, you go work better. We're doing microservices over here. We're doing Lambdas. Well, that's fine, but we've got this other thing we're gonna do with our APIs. So you end up with an unrecognizable pasta. And it works. The problem is the pasta works. It tastes good. It's nourishing. The sauce is pretty, but you take the sauce off, it's a mess. It's extremely hard to maintain because all 6 of those guys have a code base, or gals, I don't know which it was. I just inherited the app. all 6 of them had their own architecture in mind of how they were going to get their business product put out. And none of it had very much to do with security along the way. The people that were ending up selling the company when they had their cash event did a great job of building a really expensive but really profitable tool that captured market share. So, yeah.
Business is number one. Can we kill the recording? I want to tell a story. I don't want to record it.
Sure. Good stuff.
Yep.
Hang on, let me get my recorder going. Okay, go ahead.